Hello guys, welcome back to my YouTube channel. Today we will be solving three questions from the topic geometry, and these three questions came in CAT 2003, and I would say these three are very important questions. I would not say these are very easy questions. Okay, moderate to difficult level questions. So let's start. Consider a cylinder of height 8 centimeter and radius is given as r is equal to 2 by pi centimeter as shown in the figure, which is not as per scale. A string of a certain length, when wound on its cylindrical surface starting at point A and ending at point B, gives a maximum of n turns, which, in other words, the string's length is the minimum length required to wind n turns. Okay, so you have to find the vertical space between the two consecutive turns. Okay, this is the starting point, right? From here you will go here, and from here you will reach here, right? So you will complete one round from this. Again I'm showing, you will go like this, then from the opposite side you will reach this point, right? From here you will again come like this, and you will meet at this point. So when you are completing one, I am writing it, when one complete round is won, then I have created one vertical distance, right? Then one vertical gap is created, right? You can see, right? From here to here, when I'm going from this point to this point, suppose A dash, I'm creating one vertical gap. Again from A dash to suppose A double dash, I'm getting another vertical gap, right? So I am completing n number of turns, right? It is given n turns. So that means how many vertical gaps will be created? Total is equal to n vertical gaps. For when one round is completed, you create one vertical gap. How many turns, or basically rounds, you have completed? N rounds or n turns, so n vertical gaps. And let us assume that distance, or the vertical distance, okay, vertical distance between two consecutive gaps is equal to small d centimeters. Okay, so what will be the total it's, I would say, total height, total distance, it will be nd, right? Nd is the total distance, right? This is d, this is d, this is d, like this. How many d's will be there? There will be n times, okay? And this will be equal to height of the cylinder, right? So the vertical distance will be equal to h by small n centimeters. Okay, this one was moderate. Okay, I won't say easy, but it's easier compared to the next two questions. Alright, so this is our final answer, h by n. So what is the vertical spacing between two consecutive turns? It is h by n centimeters. Second question, the string, okay, the same string when known on the exterior four walls of a cube of side n centimeters, starting at point C, okay, you are starting here and ending at point D, okay, can give exactly one turn, okay, like this it will go. Then suppose I complete the cube, okay, I'm just drawing the back side, okay, about the back view, okay, suppose like this, right? Let me do one thing. I'm not able to, oh, this is the eraser area, okay, let me use, okay, suppose this is the point right here, just so that you guys can understand it. I'm drawing the back view, okay, this will look like this, right? The cube, correct? Now the string will go like this, right? From here, then something like this here, okay, then it will come here, and from this point it will come here. All right, now whenever you are asked to find the distance between 2 points, suppose I have the coordinate axis, suppose there is a point P, you have another point, suppose Q, you have to find this distance. How do you find the distance, right? You find the horizontal distance, you find the vertical distance, this will be 90 degree, and then you use Pythagoras theorems, right? So suppose P is the coordinates of P are x1 comma y1, coordinates of Q are x2 comma y2, okay. So what will be the coordinate of this? Suppose r will be, what will be the coordinate of r? Coordinate of r will be x2 comma y1, right? So what will be pq? Pq is equal to under root pr square plus qr square. What is the pr square? Pr, basically pr is the horizontal distance. Horizontal distance. What is qr? Qr is the vertical distance, right? So I am squaring the horizontal distance and vertical distance and taking the square root to get the distance PQ. This is basically Pythagoras theorem. Similarly, in this question, if I open the faces of the, or the sides of the cube, okay. So what is the horizontal distance from point C? Horizontal distance covered from C to D is equal to, from C to D, just look at the horizontal. So when I'm going from this point to this point, the horizontal distance is this, right? From here to here, this is the horizontal distance, which is n centimeters. So I'm going from C to, suppose, P, n. Again from this point, now I am actually here, okay, I am not at point P, but I am only looking at the horizontal distance. That's why I am telling you guys to focus at point D. Although I am not at point D, I am at this point, okay. So from this point I will move to this point. Again I am traveling the horizontal distance of this, which is equal to side of the cube. From this point to, when I am coming to this point, from this point to this point when I am coming, I am again covering a horizontal distance equal to the side of the square, and from this to this when I am coming, I am again completing a horizontal distance, right? Basically 4 times I am covering horizontal distance equal to n. So it will be 4 n centimeters. What is the vertical distance? Vertical distance from C to D is very clear from the figure. From C to D. What is the vertical distance? Directly C to D, right? From you were at point C initially, your final position at D. So what is the horizontal vertical distance? It is n centimeters, right? That means I can say, if I draw a right angle triangle like this, I am covering n distance vertically, 4n distance horizontally. So what will be this distance? This distance will be root over n square plus 4n square means 16n square, which is basically root over 17 n times root over 17 centimeter. So what was the question? The question was to find the length of the string. So the length of the string will be, length of the string is basically this, right? This distance L equal to this. So the answer will be n root 17, because you are going from this to this point, then from here you are coming to here, then here, and then here, and we have found this distance using horizontal vertical distance method, and then using Pythagoras theorem. So the length of the string will be n root 17 centimeters. Okay, this one I won't say it's an easy question. This is a moderate to difficult question, the question number 2. Okay, I hope my explanation made it easier for you guys to understand the question number 2. Okay, now let's try the third question. In the setup of the previous two questions, how is each related to n? Alright, I have to find the relation between h and n. Alright, h is basically the height of the cylinder. H is equal to height of the cylinder, and n is basically the length of the sides of the cubes. Okay, so let me draw the figure here. Okay, this will be, okay, so if I apply Pythagoras theorem, I will get h square, alright, plus 4n whole square is equal to n root 17 whole square. So from here I will get h square is equal to 17n square minus 16n square. I will get h equal to n. So the relation is that h and n are equal. Okay, how did I get this equation? Just see this. Okay, what is the length of the string? Length of the string is root 17n, right? Focus on the first question. Okay, this question is also not easy, so focus on the first question, this question. All right, see, the vertical distance covered is h, clearly h. What is the horizontal distance covered? I don't know, I'll figure it out, and then this will be the length of the string, right? From here I am winding the rope or the string, and then it ends at B. So this will be the length of the string only, which we have already figured out in question 2, which is n root 17. So what is the vertical sorry, the horizontal distance covered here. The horizontal distance in one complete round. In one complete round, horizontal distance covered. What is the horizontal distance covered? 2 pi r, or basically the circumference of the round, sorry, right? From here it will cover a distance like this, but I am only concerned about the horizontal distance, right? So this is making one complete round from here and then again coming back to this point. So it will cover a horizontal distance of 2 pi r, which is, again, r is given as pi by 2 by pi, so this will be 4 centimeters, right? In one complete round, horizontal distance covered is 4. How many complete round they have, like how many complete turns or round am I winding in the cylinder? N, right? We are already given n turns, so this will be 4n, right? This will be 4n. So using Pythagoras theorem, h square plus 16n square is equal to 17n square. So h equal to n. Very good question. Question number 2 and 3 especially are very important and very interesting question. Okay, I would suggest that you guys should try these 2 questions yourself and practice these 2 questions. Okay, I hope my explanation made it clear. For more such type of questions, please like the video and subscribe to my channel. Thank you.